I mean, we are passionate about solving the problem for the engineer, right? It's a security problem, but we really are helping the engineer fix the problem, right?
It's the same thing we dealt with early on. We would say free the captives a lot. You have these technical, like highly educated people that just get bogged down with horrible manual, boring tasks.
Spreadsheets from hell.
Yeah, I tell people, look, it's not sexy. You know, my wife asks me, what do you do? I go, it's not sexy. It's laundry. She goes, what do you mean it's laundry? I said, it's stuff that you know you need to do, but you don't want to do it, and you'd rather outsource it or have a tool that does it for you, right?
I love
That's
that
what we
way
do.
to say it. Yeah, people always ask, like, oh, wait, what does Paramify do? And, you know, you're at a party, and it's like, look, don't make me do it. Don't put either one of us through this. It's compliance. Let's just let it go there.
But I truly see an interesting partnership between what we do, right, at the profiling level, understanding the application, fixing the problem, and then giving you the POAMs or the self-attestations, and then feeding that into a control system that meets the requirements for different kinds of compliance.
You use the same words that Paramify uses. So everybody starts out building out their risk management profile, right? So their risk profile, what are you doing for identity? What are you doing for SASM? And so RapidFort is going to be like, you know, showing up right there, right? This is a component that we use. Oh, I also know something about what my responsibility is in implementing RapidFort, and here's what RapidFort gives me. And that's actually really important because you need actual professionals, you know, engineers. People need to know how to implement RapidFort, just like people need to know how to work Paramify.
Right.
And you could do it wrong, right? And so that's one of the things that we're trying to help solve as well. How do we help you build out those solutions? So you build out your profile just like very similar in the way we do things.
We have a lot of customers that said, you know, we love RapidFort. This is awesome. You're spitting out all the data we need. Now help me put it in a format that meets these controls. And I'm trying to I don't even understand the controls, let alone try to put in the format that needs to be, and the requirement keeps changing. And can you help me with this?
Hey, what's up, everybody? Welcome to another Paramify podcast. I'm your host, Kenny Scott, with my fantastic co-host, Mike Schreiner.
We did it. We're here again. We're here today with George Manuelian, who is the Chief Strategy and Revenue Officer at RapidFort. Thanks for coming to be on the show with us today.
Well, thanks for having me. So I appreciate you guys sending me the invite. So.
Yeah, absolutely. So yeah, tell us a little bit about RapidFort, what you guys do, you know, the space you play and all that.
Sure. So RapidFort is a company that was developed actually by a colleague of mine, a gentleman by the name of Rajiv, who is our CTO. And we worked together at Cisco originally, then another company called Color Token, security company. Then we were at Palo Alto again. We weren't actually hanging out together. It just happened to be within the same companies. So so Rajiv's interesting story there was he was given the task of Herculean task to take the Palo Alto firewall and then break it up into microservices because we were moving to the cloud, right? This is just just before COVID kind of hit. And you had to massively scale something. So you couldn't just make it monolithic, one big image. So they said, take the firewall, break it up into microservices so we can horizontally scale it in the cloud, right? Yeah. And so he worked, painstakingly. He had I'm going to get this done in 4 months. They had a team of engineers. They cranked it out. They got it out in 4 months, not sleeping, night and day, long hours. Man, I hit it. We got billion flows. We can through this thing. It's massively scalable. It's awesome. Let's ship it. And some security guy comes in and goes, whoa. You got vulnerabilities in this thing. You can't ship it. There are no vulnerabilities. And so it took him 9 months to basically go back and patch 4 months of software. And through the whole process, he said, look, every engineer's got to do this. There's got to be a better way there's got to be an automated way to do this, right? And so he started, researching, looking it out, and he couldn't find any tools, anything that's off the shelf that really solved the problem. So that sparked an idea for him to start building some tooling around how do I even know what the vulnerabilities are, which ones should I patch, and are they really critical? Do I need to? Do I not need to? So that's when he got in touch with Mihran, our CEO, and they together had worked together previously, and Mihran was doing quite a bit of work in similar space, pre-AI visual recognition stuff. So they started building tooling, and that's how RapidFort was built. And so that was almost 5 years ago, probably more than 5 years ago now.
That's awesome. That was probably about similar time you were working with Palo Alto, right?
Yeah,
There's
100%.
our origin stories converge.
Yeah.
Crazy.
So if you did anything with SASE, that was my responsibility to some extent. So
What I love about that story is it includes the fact that you built something so cool in 4 months. I thought he was gonna say he's like every other founder said we're gonna be done in 4 months, and then it's like famous last words, right? You don't finish. But the sad part is like you finish, but actually, you have the security guy comes in, and then it's actually double the time of actually making it cool. So security and implementation of cool stuff seem to always be at odds. And so it comes to a company like RapidFort where you're going to say, let's make this easy to do the right thing so that you can finish it in 4 months and not over a year.
that's exactly right. I think I have to say, in my career of 40 years, Cisco, Amazon, AWS, Palo Alto, a couple of startups that I kicked off, I don't think I've met such a high density of really talented engineers. Rajiv, Mehran, and some of the other guys are just brilliant, and their teams are just brilliant. When they put their mind to something, just step out of the way because they're heads down and they'll execute on it. And they're truly engineers. And instead of saying let's fight with security and see what's the minimum we can do, or how do I document these things so I don't have to deal with them, they said let's go fix the problem. Let's just automate fixing the problem and not find excuses why we can't or we won't fix it. And that approach is kind of at the heart of the company to some extent, right? It's how do we make life easier for engineers to meet FedRAMP, to meet CMMC, to meet all these compliance guys that are running me ragged, right? If you look at a typical developer spends 20% of their time. And so we did a survey of about 50 of our customers and asking how much time do you spend and how do you fix vulnerabilities, et cetera. About 20% on average are spending time responding to a ticket, fixing a patch, researching a patch, figuring out where it comes in. And that was in the old days, 5-6 years ago, when you had a handful of tickets, that was okay. The tickets kept piling and piling and piling up. And so now it's taking more and more time, and you've got to automate the system. You can't, there's a deluge of new vulnerabilities coming in, right? And we were talking about AI, right? AI doesn't sleep. If it figures out that there's a vulnerability, it'll find vulnerabilities in your software in 30 seconds, what used to take 30 days. Because it knows the attack vector. It's going to go and research the internet. It's going to say, oh, you're using this operating system and this version of software, and this is the open source version. Great. Here's everything you need to actually penetrate that piece of software. And it does that in a flash as opposed to human intervention.
Yeah. So in some ways, we have these new easy buttons, but we're further and further away from the actual security easy button, right?
Great interview. We had a great chat with a very large financial institution that the guy said a couple things that were interesting. One, he said, the bad news is we have 7 million vulnerabilities and we're trying to figure it out, right? We're trying to figure out how to fix this and patch it and come up to speed on this. But the good news is only 2 million are critical. So he kind of looks at me and goes, what am I supposed to do? Open 2 million tickets and then bog my entire engineering team that's going to ignore me, right? So he was telling me that they're patching 100,000 vulnerabilities per month, and there's 175 coming in and growing. So they're falling behind.
Yeah. So this is obviously an important space. What are some of the competitors in your space that you guys how do you work with them? Right.
Good question. So we started off fairly early, and so our first few customers were in the Department of Defense. The guys are saying we're taking open source software, and then we're taking stuff from the internet, and I'm putting it in a rocket or in a tank or in an airplane. Right? Probably we need to clean that up. So we were very focused at the Department of Defense. And the byproduct of that was community images. So whatever we built for Iron Bank, Department of Defense, we said, we'll open up to open community, being good citizens. And the first member of that community was a gentleman by the name of Dan Laurent. He's the CEO of ChainGuard. So we had early conversations with him. Sorry?
Well played, Dan.
Yeah, well, it's good. So we learned a lot. So I really appreciate the fact that they took those kind of open source images as a root or a basis for them, and they've evolved those, but built a business model around it. And so that gave us, kudos to him. He gave us showed us what the business model would look like for taking curated images and actually selling them in the commercial space, not just the Department of Defense. So 5 years ago, people didn't really care about vulnerabilities as much as they do now. The people who did were the the defense department or people that are on the compliance side. Now it's different. Now everything is considered to be strategic importance.
What I love about your approach is for the longest time, you heard this buzz in security, let's shift everything to the left. But your solution actually does do that. Um, for When we were going through our FedRAMP authorization, they were looking, there's a big old section where they're saying, hey, do you have anything that goes and auto remediates vulnerabilities in your environment? Well, it's like, for us, it's immutable code, right? That is vulnerability free when it goes in at the very beginning, right? And we had really good security architecture at the very beginning, and it's enabled from solutions like RapidFort, right? That really you need to be using this in your CI/CD, right? Otherwise, you're starting out with 2 million vulnerabilities, right?
You got to start clean, but the problem is that the number of vulnerabilities is increasing, and the number of new vulnerabilities is growing a lot faster than it was. So if you just wait, it's kind of like the weather. Just wait long enough, in the next day or two, you scan it again, and now you have vulnerabilities. And if you keep, it decays over time because the number of vulnerabilities just keeps growing. So not only do you have to start clean, you have to stay clean continuously, and you need to automate that process to make sure that it's continuously at every build, you're staying on top of it. Otherwise, you fall behind with 7 million vulnerabilities.
Yeah.
You talk to a lot of CISOs, obviously, probably multiple per day, and other CTOs all the time. So when you're educating them, how should they be thinking about software attack surface management? Kind of like where you're in.
So that's good. Good question there. So a couple of things that are interesting. One is that things have changed, right? We used to build everything as COTS software, and you would just buy a large or a single tenant piece of software that was COTS, and it was on a CD, and you put that in, and it was one giant piece of software, right? The universe has evolved. We went to virtual machines. And we went to virtual machines. We came up with this idea, or the industry came up with this idea of golden images. And so you would harden those VMs and you'd have golden images. And it was fairly easy for an SRE to upgrade and patch those VMs. So I get a lot of CISOs that come in and say, hey, a couple of years ago, we used to have these golden VMs. Well, what's different in the container world, right? So the container world has gone to another level abstraction on top of a VM. So where you used to have hundreds of VMs, you have thousands, tens of thousands, hundreds of thousands of containers. The containers are up and down all the time, as opposed to VMs are more stable. The other thing is that containers are a fixed code that you cannot patch, right? And so what you have to do if you want to fix something in a container, you have to go back to the developer, open a ticket, and say, hey, developer, can you bring in the latest patch or fix and rebuild that code into a container that I can redeploy? Which means there's no way for a non-developer to patch the code, right? In the VM world or an operating system, you could have a SRE or a security person patch it. In the container universe, you need to go back to the developer to get that done. And that's, I think, things have gotten a lot better with containers, a lot easier, a lot more convenient, except for patching. It gets harder. And the good news is that we're building every day. We just have to set up the right framework to build in a way that's continuously patching. Sorry, that's one thing. I think the second thing is, like we were talking about COTS software, 75% of what all of us ship as software today is open source, which means it's coming from the, quote, internet or from a bunch of different distributions.
Which is fascinating because I had no idea until we were talking before the show, and you're talking about the MacBooks that, we're all using. And it's like, yeah, Apple OS, but where does that come from? And you trace all the way back and everything's coming back to this open source software.
Yeah. BSD, Linux, from the OS side. If you think about it today, if you need a database, you don't write a database. You get Redis or Mongo, or there's lots of them there. You need a load balancer. You're going to go to F5, Nginx, et cetera. This is all open source. You need an operating system. You're not going to go write one. There's good, solid distributions that have millions of people looking at those operating systems and telling you this is good and this is trusted and it's been heavily tested. You have LTS releases, long-term releases that make sure that it's stable, right? you don't want to rewrite all that stuff. Our innovation and the code that we most of us write in software is probably 20-25% of the overall software. The other 75% is all the infrastructure software that needs to be there to run. If you look at a Kubernetes cluster, all that stuff is open source, right? All the Keycloak and managing identities and database, all of that comes from open source, right? So on average, I think 75 to 80% of what we see in most of our customers' environments are coming from open source. And even the components that are first-party software are built on top of open source. Well, what are you using to write your code? Well, I'm using Python. Well, what's Python coming from? Well, I got that from the open source. Node, I'm compiling a Go package, or well, those are all framework languages. Where do those come from? They come from the distribution, and so they come from open source. So whether it's first-party applications or third-party, which means off-the-shelf applications, a lot of it's coming from distribution that's upstream. And so what we've done is jump-started this business by saying we're the giant washing machine of open source. We take all open source software. We don't try to rewrite it like our buddies at ChainGuard do and recreate their own operating system and rewrite the rules. We are actually true to open source. We start with the open source. We trust the distribution process where there's millions of people looking at it. Right? I can't hire 1 million people to go look at a distribution of Linux to understand whether it's stable or not. Right? That's the whole point of open source. Everybody's looking at it and giving you a thumbs up, thumbs down. So we leverage the strength of open source, but we do the patching and unprecedented heavy lifting, as we used to say in AWS, to actually solve the problem of patching. Instead of you patching and you patching and you patching the same thing, we patch it once and redistribute it to everybody else. So giant washing machine that cleans open source and gives you clean base images tied to open source, independent of operating systems. So we'll run across all the major distributions. So you want Debian, you want Alpine, you want Ubuntu, you want Red Hat, all the different operating systems we support.
How often are most distributions like, so if I'm thinking of my CI/CD process, how often should people be deploying in their environment, like in terms of an expectation?
That's a good question. I think the question is, how often are you distributing your software and how often you're doing your build? At every build, like I said, this has to be systematic. So at every build, you want to make sure that you're patching. You don't want to fall behind. Some people build daily, multiple times a day. Some people build weekly. Some people build every 2 weeks. Some people monthly or quarterly. It doesn't matter. At every build, you should check, because every minute of every day, there's a new vulnerability. And so you want to patch it as soon as possible. Again, shifting left and starting clean so that you don't have to later on stop a build process to say we need to fix this, right?
Yeah, otherwise it's that endless game of whack-a-mole, right, that you're going to be playing after, right? It's just, there's no use, right? There's no way for you to keep up with it. And, vulnerabilities are just one of the attack vectors right in there. And so
So interesting, the Verizon breach report. I don't know if you guys read the one from 2024, 25, I think it is. This is the first time in history, in my career of 30 years in cyberspace, that vulnerabilities in software are now the number one breach vector looking backwards over the last 12 months. It used to always be identity and identity theft and all that stuff. Either we've done a really good job or AI is doing a really good job at vulnerability attacks. But vulnerabilities have surpassed, I think it's somewhere like north of 32% of the 32% of the breaches came from vulnerabilities. Yeah.
And that's driving some of the changes in FedRAMP, right? If you have something that's internet facing, and if you have something that's going to be, it's likely exploitable, there's been a big change, right? There's the new Vader standard with 20x that's come out. Typically, we had, if we're thinking back on golden images, that the expectation from DoD or from FedRAMP was like, hey, any critical vulnerability you need to close the next time you do your POEM report. So 30 days, and then 90 days for moderates, and then 180 days. You said one of the magic words for us, excuses. That's actually what we call our deviation requests. Like in platform, we call it excuses. And so you need to be able to manage those. And some of them are really funny, and they're just like never going to patch it. But that has to change. So now, for those, if you're using a tool like RapidFort or something, you're able to see, like, hey, is this likely exploitable? Is this internet facing? And if it is, you probably have a half a day where you need to half a day window or less where you absolutely need to patch that.
So reachability is a bit of a phallus in some sense, right? Everybody thought, if I put a firewall in front of my data center, it's not going to be reachable. People jump over that fence all the time. They get into your container. If that container is not hardened, if that container is leaving all the tools for the bad guys to do things like VPN out or ping your next door neighbor or curl or bash or add packages, then you're leaving all the tools behind. It's not about reachability. It's about what packages can I add? What tools can I use that you left behind to really create havoc, right?
Yeah, I'm glad you said that, right? Because that's what everybody says. Oh yeah, it's behind a firewall. Like no one has access to this, but that's
There's no direct internet access to this specific application. Like, well, if I log in as an administrator and I get access to the container, I have access, and then I can do other things and rewire and reconfigure the cluster to do whatever I need to do. So again, if you fix it, if you remove if you harden the images, so we have two concepts here. Really, it's quite simple. One is start with clean, fresh images, patch everything you know how to patch, and then the second aspect is taken really from NIST, and we're working closely with NIST on this. Is remove the things that you don't need, right? Think about your phone, right? Your phone has 150, 200 apps running on it. How many apps do you use? 4, 5? What are the other?
I actually couldn't install my latest iPhone thing. Let's
No
see.
storage.
It says you don't actually have storage, and then I went to it. I'm like, okay, well let's remove some of the apps. I'm like, I kind of need that, and I'm like, do I really want to delete that book all the way? I'm like, yeah. I'm like, all right, I guess I'll
But
do
think
it.
about this.
But yeah.
All the other apps are spying on your 4 apps that you use.
I know.
Right. So
I know.
Again, the concept with minimizing the attack surface is removing every piece of software that's not critical for the mission. If you don't need that piece of software for the mission, it is a risk. Whether there's a vulnerability today or there's going to be a vulnerability tomorrow, remove it. If you're not using it, remove it, right?
Let's talk a little bit about that, like the risk. We're one of the things with 20X is it's trying to adapt to like civilian agencies, right? Civilian-based agencies. DoD is not moving that way yet. They're going to wait for 20X to be formalized, and I think they're really intrigued to see how that goes. But DoD is not there yet because the mission is totally different. So you guys have customers that actually might be deploying like missiles or things like that, right? So like what
Can't talk about it, but yes.
Yeah. So talk a little bit about that, right? And so what is the difference between your different customer bases, right? So
we have obviously, IL5, IL6 customers. We have over 40 customers that just went through FedRAMP also this year. I was just looking at it. Then we have ATO'd customers, and then we have customers we don't really talk to. They're like, drop off the software at the corner of this S3 bucket, and we'll call you if there's a problem. But fundamentally, we started off in the Iron Bank, helping Iron Bank build hardened images. They use quite a bit of our tooling to do that. And so that mission was around hardening the software, removing the unused components. It was less around sort of patching, much more strict around removing the unused components and minimizing these massive attack surfaces. If you're bringing a server that you need in a specific program, and that server has a Bluetooth driver, and you don't use Bluetooth, then that's just a liability, right? Why are you using these things? If you're using, if you are using software that has all kinds of other mechanisms to extend out to other containers, or has the ability to add packages, or has the ability to run specific code that could be injected, all of that, if you're not using it, is just making you liable in the future for that to get hacked. So we learned quite early on, and quite a few of the patents that we have around hardening is all around understanding what you're actually using, what's mission critical, and what is superfluous and not needed. And so we started backwards. We started by saying remove stuff you don't need. And then we used our own tooling to then go back and build clean, curated images. So they kind of go hand in hand. And so you were asking me sort of who, in this market, there are, 2 horses that are running the race, and there's about 20 ponies in the stable ready to come out that just announced a few months ago. It's ourselves and ChainGuard, right? And so ChainGuard took the approach of everything's going to be minimal. We're going to start with scratch and distroless images, and then we're going to then recreate the operating system and do a proprietary OS and proprietary packages and redo everything, right? So good luck to them. They'll have to basically hire millions of people to do what basically the distribution does today, having millions of eyeballs doing that, right? We've been able to take quite a few of their largest customers away in the last 12 months, about 14, 15 customers at last count, mostly because they want to use open source. They don't want to use a single source, right? So the difference is between, do you rewrite software and sell software, right? Is this VMware, Broadcom all over again? And so therefore there's one piece of software, and so trust me, it's mine and it's going to be good. Or do you truly believe in open source, which is the distribution will find a way to catch any of the issues because there's so many eyeballs looking at it, right?
Yeah, so tell me more about that. Is that because the customers ultimately want not just, it's not like they have this idealist view where it's like, well, we need to have open source. Are they looking for the functionality?
Well, let's work with the practical stuff, right? If you use open source, there are certain rules you have to follow, but in general, it's yours to use, right? And if you use it in your application, and that goes into an airplane or a car or a steam engine, whatever you want to call it, right? There are no regulations around you having to rip out that software if you stop paying somebody. If you buy a proprietary operating system that is owned by a specific company, if you stop paying them, you actually have to rip out the software, right? So that's the fundamental difference about, do you want clean open source software that everybody can share, or do you pay for a subscription to proprietary operating system that at any point in time can basically meter you, or you have to remove the software. So it's very painful in the FedRAMP process or any of these embedded systems to deploy software that you can remove. It's not easy. You don't go in and change your operating system or things like that. So a lot of these customers have come back to us and said, look, we used third-party applications from like a ChainGuard because it was okay, because those are easily substitutable. But when you come to first-party application where we're writing our code on top of it, it's not easy to substitute. So we want something true to open source that you don't own. They're paying us to clean it. They're not paying us for the software. That's the difference. So we don't have any claims on our software, as in it's not ours. It's open source. Our job is just to make sure it's patched and clean and handed to you. We've done the same work you would do. We're just doing it for you, so it's outsourced.
Yeah, and you guys are using patches that you guys develop, or it's
so interesting. So if you think of containers, it's kind of 3 layers. There's an operating system, there's a framework, and then there's the actual application that runs on top of it. So a lot of these software manufacturers they need all 3 stacks. So either they'll fix their own application and say, hey, my stuff's clean, but I'm not going to go fix the operating system, or I'm not going to fix the languages because that's not me. Again, 75% of that software came from somewhere else. So I can't fix somebody else's software. I'm not going to spend the time doing that. So we facilitate that by doing the entire stack. Now, lucky for us, most of these patches, especially the critical ones, are available. They just might be in a different release, or they're further upstream. We pull that upstream and we backport them, patch it, and QA it and test it. So like 95% of that software is coming from the original developers. It's just we're making it available in that format and version number that's needed for that developer, so they don't have to be forced to upgrade to something that might break their application. On a rare occasion where there's something that's critical and we got a call from somebody that's important that says, I need this fixed in 7 days, we do go in and we will patch those ourselves, and then we will then resubmit that code, that source code, into the open source so that it's redistributed across the distribution.
That's awesome.
Yeah. You guys get a lot of data, right?
We
comes out.
We have a lot of data. Yes. That's right. And we have to basically be in touch with thousands of upstream software distributors and understand their rhythm of releasing software and how they're patching this, right? There are competitors that are saying, oh, we're just going to buy out or pay these developers to give us code first. But that's not the spirit of open source. The point of open source is you have millions of eyeballs all checking on each other. Anybody cheats, anybody puts something in that's different, the whole world will know, right? Again, if you try to do this behind closed curtains and you try to make it proprietary, how do you test all that? How do you know that you're actually doing the right thing without having millions of people kind of looking at it? So the traditional distribution of open source is time and eyeballs. Given enough time, enough eyeballs, everything will be found. If you bypass the distribution, you lose the benefit of open source, which is time and eyeballs, right? And so I think that's the fundamental difference between what we're doing and some of the upcoming competitors are doing. They don't have the tooling that we've designed and built with the Department of Defense. We have, I think it's public knowledge, we have, I think, over $14 million in contracts, when our nearest competitor has about $200,000 in contracts. A lot of that has gone into R&D to rebuild this tooling to get to optimizing for the mission. Patch what can be patched, remove what's not needed, only deliver the minimum amount of software to execute what you need to do. Why? Anything that's superfluous is a threat to you, right? We are at war. I think you guys, know this, right? We are at war at the national level. We're at war at the business level. You guys saw, the power go out in Spain. I was in Spain this summer. Power in the whole country went out. Spain, Portugal, and parts of France. Was that coincidence? I don't know. You tell me. We had our pipelines hacked last year, natural gas on the East Coast, right? So this is happening everywhere. And so coming back to your original question, yes, FedRAMP is where it's starting, and the government's doing a great job of enforcing this for companies that are working with the federal government or the federal government themselves. But this is now going into FDA. So I don't know if, as of June, for example, FDA is saying if you want to ship a medical product that has software in it, it needs to start meeting FedRAMP-like requirements, CMMC-like requirements. You have to have 0 CVEs. You have to have a monthly attestation. Show me your SBOM, show me your RBOM, your real bill of material of what you're actually using, and show me that you've stripped out the things you don't need and you've hardened your software.
So they're kind of enforcing this from their end.
It's there. If you are a financial institution in the New York area, there are regulations around meeting CMMC-like rules. And we expect the same thing to come in the energy sector. And all of these things are critical infrastructure for us, right? And again, if your 75% is coming from open source, how do you protect? How do you protect that infrastructure?
Yeah. I was actually in Costa Rica this summer and the power went out a lot, but it just happens. That's just what happens, man.
That's normal.
Theirs is intentional. They've not built the infrastructure so they can keep their country a rainforest.
Yeah.
Which I appreciate. I think it's awesome.
Yeah. That beach is awesome.
But then you get power outages.
Yeah, that's fine.
Or extort more money, I guess.
Yeah,
You
maybe.
can get a generator.
Yeah.
Get a generator.
Now that's fascinating. So are most of your clients looking into RapidFort because they're pursuing something like FedRAMP or CMMC, or is it not necessarily compliance driven? It's part of their security practices?
When we started, it was 100% DoD. As we started expanding, we found the DIBs that are now servicing the government, right? So they had to comply to government regulations. Now we're seeing with CMMC is the suppliers of the suppliers need to meet those regulations. If something's going to go into a Boeing aircraft, even if I'm a supplier to Boeing, who's a supplier to the government, all of that now has to run. So that was kind of the first, second, and third ring of customers. Now what we're seeing is mainstream customers. Even Fortune 1,000 or 5,000 customers are saying, we might not be able to get cyber insurance if we don't prove that we were consciously managing our software in a way that was reasonable, right?
And how does RapidFort help with a company that's like you're just approaching them, right? So it's a bank, for example, and banks honestly they've kind of been like the OGs of cyber, right? Because back in the day, even before you had all these nation state threats you've had them for a long time, right? But banks were where the money was, and so criminals, they're just like, hey, they've always been target number one, and that continues to this day. And so they're always going to be trying to reduce risk in any way. So I can see that that's a huge greenfield for you guys. But What about a new company that's coming to you? How can you guys help them?
So yeah, we're seeing that the work that we did for DoD and the DIBs, et cetera, is directly relatable to any kind of commercial customer, whether it's banks or energy companies or security companies, et cetera, right? We're all using the same open source software. So once we patch it for one company, we patch it and we can maintain it continuously. We're now offering it up to everybody. So it's a get out of jail free card in the sense that there's an easy button to fix the problem that used to take lots of engineering cycles, right? We believe that 20% of developers are wasting their time patching or fixing these things. If we believe, again, from our surveys that we've done with our customers, 80% of that load goes off of them if they're able just to use curated images.
Got it. So you can plug in, you can say, I know which version of Red Hat you're using. We go scan them and we know exactly what patches to do. Here's your new image, right?
Well, I need
And
Red Hat and I need Python on top of it.
yeah,
and then I need
your whole
this on
stack.
top of it. Yeah,
I
the whole
need the whole
stack.
stack
Yeah.
because I need it to work.
Right.
That's great.
Yeah.
Yeah, I love that.
And it comes in kind of two packages or two formats. I just need a database. Just give me Mongo that's Bitnami compatible that can run this function. I mean, I don't really care about the operating system. Just give me the smallest or the one with least number of CVEs or the one that has a STIG, for example, right? STIGs are only available for Ubuntu and Red Hat today. So if you need a STIG, you might have to move off of Alpine or off of something else to get to that, right? Or if you want a small footprint, you might move to Alpine. So it gives you that freedom. But fundamentally, you're not that worried about the operating system. You just need the function from a third party to be clean, hardened, and ready to serve. And then you have first-party applications, very different. There, I'm going to build on top of the operating system. So I need to make sure that the packages that I'm going to pull in, my dependencies, are open source and they're available. There's 9 million packages out there. If I'm going to pull in packages, I need to make sure that they're going to work the way I would expect my application to work. And if I have to change trains and I need to jump from package manager A to package manager B or a different distribution, now I have to touch every single one of my Docker files. I have to change the way, I have to look at the dependencies and all that stuff. So we're making it easy for them because we are matching their existing build systems. That's why we say we remediate 95% of software vulnerabilities with no code changes. We don't see and we don't touch any of the source code, but everything that you're doing from third-party software, we make it binary compatible to what you use today. So I can swap out all the Lego pieces underneath with no impact to your software because they're identical from upstream.
Yeah.
Right.
And so that involves analysis at the very beginning, right? So you're scanning
we profile. Yeah, we do a very good job of profile. So one of the things that we do that's unique to the company is we profile your cluster or your in the build time, and at a very detailed level, give you a very accurate bill of material, but also a real-time bill of material, which says what's running, what are the components, what's the version number, where are the fixes. So we know what is binary compatible and what we can swap out with minimum impact to your software.
Yeah. And so, yeah, I like that because it's kind of a first principles approach. What do you absolutely need? What can I take out? And this is all on the platform. That's really cool. That's a really interesting approach.
I have a dumb question. Are we still allowed to call it the DIB, or do we have to call it the WIB?
The WIB. I like that.
To call it the WIB?
Yeah.
It sounds less threatening, though.
Yeah.
Well, they call them the Beltway Bandits. That's what I heard. But
And better than the WIB.
Yeah.
Okay.
Yeah. I've just been saying Department of War and Associates.
Dow, different Dow.
Yeah.
Yeah.
So you guys posted something a while back talking about AI coding. Obviously, it's kind of all the rage. You guys hire engineers. We hire tons of engineers. And AI is doing a ton of coding in today's world. You guys had a thing where you were talking about how that can be a threat at the same time. Dive into that a little bit.
Sure. You can either embrace AI or you just get run over by it. I think that's the only two options. So it's just a matter of time till everybody's using AI, and obviously coders are starting to use it, and it is much more efficient. It's a force multiplier. Your engineers are 2, 3, 4 times more efficient. There are a lot of benefits, of course, and quite a few of our customers are AI companies. So also what's interesting is that AI is another vector of breaches, and so anytime you deploy AI, now people want it on-prem. So these AI companies are looking to harden their own images, because the first thing you're going to do when you put AI into your environment on-prem, you're going to say, how do I know you're clean? And you're not going to get breached. So there's a whole ecosystem of customers that we have there, which is wonderful. But AI also can be used in a couple of different ways. One is that when you write code with AI, you're not in control necessarily of all the dependencies that AI will pull in to build the function that you need.
You're abdicating the logic to something.
You're defining it at a higher level and not defining specifically the packages and things that are coming. So you're less in the weeds, so you can move a lot faster. But it also means that you're pulling in a lot more code and a lot more functionality, or a lot of packages and files and things that might or might not be critical to the mission. So we're seeing a major bloat in software. And that bloat is from pulling in multiple different dependencies and libraries that you as a coder might have not known about. But AI sees everything, so it's pulling in lots of different options for you, which bloats your software. Again, increasing the attack surface.
Yeah. So it goes kind of full circle to that description at the very beginning. You coded something super fast, and now you have more than twice as long remediating everything, fixing it. So you need a tool that can help diagnose, quickly. I was just
going to add one more thing there. So you can build, if you're building Greenfield, it's pretty easy to build distroless or scratch images. And we have a whole system of building scratch and distroless. The reality is 90% of software is not from scratch. It's existing software. The developer's not there, but I still have to maintain it and I still have to clean it. And majority of software is of that nature. If I'm starting from scratch and really early, I can probably write it really, really tight and remove all the things that are not needed, maybe if I don't use AI. But the reality is it's only a matter of time. It gets in the hands of multiple engineers, and that's just going to bloat, and it becomes brownfield. As soon as it becomes brownfield, I don't have the choice to go back and manage every single file and every single package and every single application. It becomes unwieldy. So that's why I need the mechanism to profile it in runtime to understand what's there, to then shave it back down to size to what I really need.
Yeah, no, 100%. Okay, so another thing we talked about at the very beginning, security tends to be at odds with progress. A lot of times it doesn't do functions. So talk a little bit about how you explain the ROI of security to your customers.
Really good. Good question. I have one slide that's kind of like the go-to slide when I'm presenting from a sales perspective. It's an example of many different examples that we have, but a customer came to us in October of last year, and he said, I need to be IL5 fully compliant by December. And I just said, look, realistically, this is going to take a lot longer. So I said, let's start with basically, do you understand your environment? Do you know what you're using and not using, and what are the vulnerabilities, right? So the first thing they did is we profiled their cluster, and it came back as 3,582 CVEs, something like that. And so the guy said, all right, based on my calculations, this is going to take 6 engineers, probably 3 months, assuming there's no more new CVEs coming in, for these guys to go figure out every single CVE, patch it, and rebuild it. And just don't bring in any more CVEs. We'll catch up, right? And he says, I don't have that time, right? So then what we did is we profiled it, and we said, all right, based on the profile, here are the base images you're using. Here's the framework images you're using. Here are the third-party images you're using. Oh, and by the way, we can swap them out dynamically for you. And so we were able to swap those out dynamically. Went from 3,500 CVEs down to 500. Now he goes, well, my God, I did this in one build. It was, I think, 2 hours for his build. When his build was finished, he swapped out those base images. It went from 3,500 CVEs to 500. So he was like, holy tomoly, I'm there, like in a couple of hours. This is, instead of hiring 6 people or pulling 6 people off the line to do this. So there's your ROI. It's usually 2 to 3 months. But then the question was, why are there 500 CVEs? You gave me pretty clean images. Shouldn't it be like in the teens? So when we go back and investigate, when you start with clean images, one of the tricks is removing all the packages. So you start smaller, so it's cleaner. But as a developer, you need to add those things. If it's a Python graphics language, for example, it's got 3,200 files. Do you need all 3,200? No, I only need those 200 files that I'm using. Great, you can use the other 3,000. So their application actually, after profiling and swapping out the base images, we then did our hardening process. The hardening process took it from 1.8 gigs down to 262 megs. Because all that other stuff was junk that wasn't critical for the mission. And that went from 500 CVEs down to, I think, 3 that were not patchable at that time. So this entire process took a week, what would have taken 6 engineers a couple months to do.
Yeah, you're so dialed in on the problem. Like, yeah, your founder is so dialed in, knows exactly how to solve this specific problem, and security is vast. This is one of the aspects, but that's why we like working with companies like RapidFort, because we know exactly what solutions are needed in this whole landscape. You mentioned IL5 and GRC and security are pretty much tied together now. What are some of the future trends that you see in that space?
Yeah, this is a good, really good question. So I think we have to tie into the automation aspect of this, because manually patching or having human intervention in the system is going to make it so we keep falling behind, because the number of CVEs, number of bad guys are going to increase. So we need to automate it and make it in every build in an automated fashion, which means we need to automatically understand what needs to be fixed and then fix it in the build pipeline. So what you'll start seeing actually from us and some of the things that we're about to announce is build systems that automatically remediate, they profile and remediate your software during the build, right? So if I can automate that process, then engineers now, 20% of my engineers can go back at actually writing functions and new code instead of wasting time trying to fix this stuff. And we fix it in the build path for them, then that's a huge relief and a much more productive engineering cycle.
Kind of a loop of continuous security architecture,
Yeah.
continuous execution of the solutions,
That's right.
and then continuous reporting. Just kind of
And continuously learning what's going on in the runtime that influences the build time. Hey, you started using these the 3 libraries. Of these 3 libraries, you're only using 10% of them. Do you need everything? Oh, now you added this new function. Do you need that function? So how do you know that? You have to monitor it in runtime to influence the build time. Just giving you a couple of clean images and going, good luck, is gets you about 65% of the way there. We're in it to kind of win it in the sense of we want to remediate 95% of the vulnerabilities.
Yeah, man, I love this podcast. This is so good. I've learned a ton today, and I think our listeners have too. And it's really good to understand the differences between the options, because some options are going to work for others, and some are going to, those different circumstances. This is a huge problem. Cybersecurity is basically infinite in scope, and it's growing. So yeah, super glad you came in. George, tell us a little bit more about how our listeners learn more about RapidFort. How do they connect with you guys?
Sure.
Like, how do they learn more?
Where do they find you?
Perfect. So www.rapidfort.com. Just click on the link there and you can set up a calendar invite to jump in and have a conversation with us. Or if you want to use the tools, you just fill out, there's a form and we'll give you access to the tools and play around with the images and figure out what helps you. I mean, we are passionate about solving the problem for the engineer, right? It's a security problem, but we really are helping the engineer fix the problem, right?
It's the same thing we dealt with early on. We would say free the captives a lot. You have these technical, like highly educated people that just get bogged down with horrible manual, boring tasks.
Spreadsheets from hell.
Yeah, I tell people, look, it's not sexy. My wife asks me, what do you do? I go, it's not sexy. It's laundry. She goes, what do you mean it's laundry? I said, it's stuff that you need to do, but you don't want to do it, and you'd rather outsource it or have a tool that does it for you, right?
I love
That's
that
what we
way
do.
to say it. Yeah, people always ask like, "Oh, wait, what does Paramify do?" And, you're at a party and it's like, "Look, don't make me don't put either one of us through this. It's compliance. Let's let it go there."
But I truly see an interesting partnership between what we do, right, at the profiling level, understanding the application, fixing the problem, and then giving you the POAMs or the self-attestations, and then feeding that into a control system that meets the requirements for different kinds of compliance.
You use the same words that Paramify uses. So everybody starts out building out their risk management profile, right? So their risk profile, what are you doing for identity? What are you doing for SASM? And so RapidFort is going to be like, showing up right there, right? This is a component that we use. Oh, I also know something about what my responsibility is in implementing RapidFort, and here's what RapidFort gives me. And that's actually really important, because you need actual professionals, engineers. People need to know how to implement RapidFort, just like people need to know how to work Paramify.
Right.
And you could do it wrong, right? And so that's one of the things that we're trying to help solve as well. How do we help you build out those solutions? So you build out your profile just like very similar in the way we do things.
We have a lot of customers that said, we love RapidFort. This is awesome. You're spitting out all the data we need. Now help me put it in a format that meets these controls. And I'm trying to I don't even understand the controls,
Yeah.
let alone try to put in the format that needs to be, and the requirement keeps changing. And can you help me?
And
with
the
this?
interpretation thereof.
Right, exactly.
Right, of the requirement. Yeah. I remember when I was just starting Paramify, I just had this embarrassing prototype. I think we had 3 people at Paramify, and I was like, hey, I'm just going to go out and try to sell this thing. And so I went on the floor, at a RSA, and I went and talked to everybody, and I said, hey, is FedRAMP a problem for you? And everybody's like, oh my gosh. And I realized I was talking to salespeople, right? So they're like, oh yeah, bro, come on, let's talk. But I do remember RapidFort, and I remember by name, some of the people that I met. And it's really, you guys had a smaller booth back then, but now you guys are much bigger now.
Unlike a lot of our competitors, we didn't raise hundreds of millions of dollars. The difference is that we're profitable. And so we're even asking ourselves, do we need to raise more money? So every day that goes by, we're just making more money, which is great. And we're really focused on solving the problem. We have competitors that have got a lot of money and they're doing a great job of marketing. So we just have to, as people get to know who we are, we're winning these deals. So we are doubling and growing super fast, but we're doing it in a conscious way, in a profitable way, not just throwing money at marketing.
Yeah, you guys are doing awesome. I really appreciate you coming out. This is awesome.
This has been great. Let's do it again.
Yeah, this is awesome. So thanks, guys. I really appreciate the invitation. This was wonderful. Great, good questions, by the way.
Thanks, man. Ciao, guys.